Is how much space the piston takes when it moves up and down in the cylinder. You can figure out the displacement for one cylinder, and the way you do that is you take the area of the circle made by the top of the piston and multiply it times the stroke of the piston, or the height of the movement, and that tells you the displacement for one particular cylinder. Multiply that times the number of cylinders, and you've got the displacement for the whole engine. Let's take a look at the formulas for that. First of all, the area of a circle is pi times the radius squared. So if you can find the area of this circle at the top of the piston by taking pi, which is 3.1416, and multiplying it times the radius squared. Now, the radius is from the center of the piston out to the end, or out to the edge. Very often, they'll give you the entire bore, the entire diameter of the piston. They call that the bore when you're talking about a piston. And so if you get the bore of the piston, you have to take that diameter and divide it by 2, and that gives you the radius. And so let's take a look at the displacement then for a particular cylinder would be pi times the bore, which is the diameter of the piston, divided by 2. You square that because it's pi r squared, times the stroke. And if you want it for the entire engine, then you'd multiply it times the number of cylinders in the engine, and that would be the displacement for the entire engine. Now let you and I take a look at the way they're going to ask you a particular question about this. They're going to say, what is the displacement of a piston that has a 1.5-inch diameter bore and a stroke of 4 inches. So let's see, 1.5-inch diameter, but that's a bore, and so half of that would be 1.5 divided by 2. So you take pi times the diameter divided by 2, and then you square it, and then the stroke is 4 inches, so times the stroke, which is 4. And so again, it's 3.1416 times, and 1.5 divided by 2 is 0.75. Let's do that with a calculator real quick just to make sure you know what we're doing. And we'll take the 1.5 divided by 2, and you get 0.75. Now, we're going to square that later on, so let's go ahead and multiply that time itself, times 0.75, and we'll see what that is squared, and we get 0.5625. So now we have 3.1416 times 0.5625 times 4. So if you want to go ahead and just multiply all those out, we can find out what the displacement is. 3.1416 times 0.5625 times 4, and the displacement then works out to be just about 7.0686 inches. Now that's the displacement of one cylinder. Let's you and I figure out the displacement of a 4-cylinder engine. They're going to give you a question that goes like this. Let's take a look at it word for word. They say a 4-cylinder aircraft engine has a cylinder bore of 3.78 inches, and the cylinder is 8.5 inches deep. Now, with the piston on bottom center, the top of the piston measures 4 inches from the bottom of the cylinder. What is the approximate piston displacement of this engine? All right, now let's take a look at it. First of all, you take pi, and remember this particular cylinder had a bore of 3.78. Let's you and I use the calculator and find out what the radius of that piston is. So you take 3.78 divided by 2, the bore is the diameter, divided by 2, and we find out the radius is 1.89. That's how we got that 1.89. So you take pi times the radius, which is 1.89, and that's squared. Now, if you remember, they said the piston on bottom center, the top of the piston was 4 inches from the top of the cylinder. And when it's the whole cylinder is 8.5 inches deep, so what that tells you is the displacement is 8.5 inches minus 4 inches, or the stroke is 8.5 inches minus 4 inches. And there are 4 cylinders in this engine. So now let's continue with this. You have pi, which is 3.1416, times 1.89 squared. So let's just multiply 1.89 times 1.89, and you're going to find out it comes out to 3.5721. And now you take the 8.5 minus 4, and you find out the stroke is 4.5 inches. And there are 4 cylinders. So we have to multiply all those things together. So let you and I go ahead and multiply all those things together, and we'll figure out this displacement for this entire engine. Okay, let's use the electronic calculator. 3.14 times